First, let us go through the three trigonometric ratios: sine theta, cosine theta, and tangent theta. So these three trigonometric ratios come from a right angle triangle. We have theta here, so this side would be the opposite, the adjacent side is this, and the hypotenuse. So sine theta is defined as the opposite side divided by the hypotenuse. Cosine theta is adjacent over the hypotenuse, and tangent theta is defined as the opposite over the adjacent side. So the three ratios sine theta, cosine theta, and tangent theta are ratios, while theta itself is an angle which can be expressed in terms of degrees or radians. In our studies of additional mathematics, it is very common for us to express our answers in exact forms. The reason why we want to do this is that there are some questions that specifically requested you to leave the answers in exact forms. Sometimes the questions may ask you not to use calculators to work out the answers, even though you may bring in your calculators for an additional mathematics examination. So in such cases, you know that you will need to express your answers in exact form, which means that you should not use your calculators to determine any of the trigonometric ratios. So next, I'm going to explain to you how to achieve the exact forms for some of the ratios of special angles. The special angles that we are concerned with are the 30 degrees, 45 degrees, 60 degrees, and on top of this we have 90 degrees, we have 180 degrees, and of course 270 and 360s, which can all be derived from some of the ratios that you get. So of course we also want to know how to get the ratios of these angles that are expressed in radians. To help you to remember the ratios of these special angles, what I would recommend is just remember this particular ratio: sine 30 degree is equal to half. This will also apply to the radian angle, which 30 degrees is pi over 6. So you can draw a right angle triangle like what you have here. So if you remember that sine 30 degrees is half, that means the opposite would be a 1 and the hypotenuse would be a 2. Based on these two sides, you can calculate the adjacent side using the Pythagoras theorem, and that will give you root 3. Okay, so how do we do that? Adjacent square is equal to the hypotenuse square, which is 2 square, minus the opposite side square. So you have a 4 minus 1 is equal to 3. So the adjacent side would just be a root 3. So we have this root 3 here, and once we have these three sides, we can obtain the trigonometric ratios for 30 degrees and 60 degrees. Now we will try to complete the table using the diagram that we have constructed earlier. So if our theta is 30 degrees, we will have a sine 30 degrees. Okay, sine 30 degrees will be equal to opposite over hypotenuse. So that sine 30 degrees will give us half. Okay, so same thing, cosine 30 degrees, okay, is adjacent over hypotenuse. So that gives us root 3 over 2. And tangent theta, okay, tangent 30 degrees will be tangent opposite 1 over adjacent root 3. Same thing goes for 60 degrees. sine 60 degrees is opposite over hypotenuse. So that gives us root 3 over 2. And cosine 60 degrees will be adjacent over hypotenuse, half. And lastly, tangent 60 degrees is opposite over adjacent. So that gives us root 3 over 1 is root 3. So here we can identify this, that sine 30 degrees is equal to cosine 60 degrees. The same thing goes for sine 60 degrees is equal to cosine 30 degrees is equal to root 3 over 2. So this is half. Okay, next we will want to construct the triangle for 45 degrees. This is for us to obtain the ratio of sine, cosine and tangent 45 degrees. So a right angle triangle with one angle 45 degrees, it means that the other angles is also 45 degrees. So if you were to construct a table where theta is equal to 45 degrees, which is the same as pi over 4, then we will have a sine theta, cosine theta and tangent theta. Okay. So you can see that when you do a sine 45 degrees, so sine 45 degrees will be opposite over hypotenuse. So that will give us 1 over root 2, and cosine 45 degrees, it will give you the same ratio. So cosine 45 degrees will also give you 1 over root 2. Then you can see that sine 45 degrees is equal to cosine 45 degrees and is equal to 1 over root 2. And our last ratio will be a tangent 45 degrees, which is opposite over adjacent, and that will give us 1. Alright, so that goes for all the trigonometric ratios for special angles.